Thank you.
Hi, my name is Caleb Johnson. I live in Durango, Colorado. I'm a junior at Animas High School. Some things I learned about, like when I was making this kit, was like programming it mainly and problem solving, because some of the things didn't work as I intended them to, and I had to go and tweak that a bit. And my favorite subjects at my school are chemistry and humanities, which is kind of like U.S. history. It's like a table of contents. Like the first thing that I did for making it, first the interface, well, the program that you use to program this, it has some instructions that tell you how to like build and program like these basic models of robots. And I made the shooter bot. Basically, it'll turn around in circles and then like shoot these little plastic balls and stuff whenever something gets within a certain range of it. And that helped me like get used to how the programming worked and taught me how to program it. And I found that very useful, going and doing some like real stuff that it has tutorials for, because it tells you, like, if it doesn't do what it says it's supposed to do, it'll give you suggestions on what might have went wrong to build it. Like I use like the basic model for the shooter bot, except I moved the color sensor and I moved it over here, and I removed the little shooter piece, and I had the touch sensor here. I decided to actually replace the little color sensor with this ultrasonic sensor, which can see if something's within a certain distance of it. And I basically changed the location of the ultrasonic sensor because it was originally up here and wasn't detecting all the time. For when I programmed it, basically I made it so that it'll go forward until it runs into something, because when it hits something with the touch sensor, and it'll use this ultrasonic sensor to sense if something's within 9 inches to the side of it. And if there is something, it will turn this way and continue forward. And if there isn't something, it will turn this way and continue forward instead. For making the maze, like when, like the maze is that thing over there on the table. I was originally going to use some foam board, but I decided to use pegboard instead because it was more stable. Like some of the problems that I encountered was the ultrasonic sensor wasn't actually detecting all the time, and sometimes it would just turn to the wall, and that was kind of problematic. The way that I fixed that was I increased the range of it, because it doesn't, like, it wasn't detecting as far as it was. Like another problem that I encountered, if I can finish that line, was that it doesn't always turn like exactly 90 degrees, which is what I was trying to do for the maze. So I had to go and change that a bit, change it up a bit. Yeah, and like my final thoughts, I thought that the Mindstorm kit was easy to use after I went and did some of the basic programs that I had in there. And doing the basic programs were very helpful in learning how to program it. Yeah.
And so they give you instructions in the.
Just a second, like this is what the user interface looks like. You can see here that it has like these like the logo thing, it has like these quick start things, and it will have and it has instructions like how to build it, like how like step-by-step instructions on how to like assemble the thing. And it has a programmer guide over here, and it will give you step-by-step instructions on how to program it, like this, and like what to put in each of the boxes. And then for the test guide, it seems like that has a little test method that comes with it. It's supposed to go forward and stuff, and then basically it has these little suggestions, like it says if it doesn't automatically reverse, like you might check like the second boot block to see if you did something wrong with that. And I found that very useful for like when I was troubleshooting my robot, like because sometimes it wouldn't do exactly what I wanted to do, and the suggestions that I had in the tutorial helped. Yeah, and like I've been talking about the blocks here. Like in the program, like this block here, the one that I just clicked on, the one that you see going all the way around it, that's it's a loop. Basically, it'll keep on repeating everything in the loop for the set amount of time forever. And like this is the touch sensor, so when it touches something, it'll do one of the two actions. Like this, it'll do this action if it doesn't run into anything, and it'll do this action if it does run into something. So when it does run into something, it'll use the echolocation sensor, and it'll see if anything's, and basically if there's anything within 9 inches or less, it'll go execute this move block. And if there isn't, it'll execute this move block, and it will repeat. And it'll keep on repeating the set of commands that I have here until I turn it off, basically. Yeah. I'm going to show you the program now. Like it's over here. This is
I think it's easy to see.
yeah, I already have the program.
Stretch.
Yeah, this is. Okay. And yeah. And yeah, I haven't been able to get it to turn exactly 90 degrees, so it doesn't always go up the way that I'm planning. So, yeah.
So, sorry, did you program it to always turn left, always turn right? If you were looking at the maze and you
no.
were planning on what it should sense?
No, like I programmed it so that basically I have it so that it'll basically go when it hits
Till it
this,
bumps, yeah.
then when it bumps, it'll go use the echolocation set. They'll use this sensor to see if there's anything in this direction, and if there isn't, it'll turn this way.
Okay.
And it goes forward here and bumps here, and it sees that something's here, so then it will turn this way.
Okay.
And then it does the same thing for this spot, and nothing's here, so it turns this way. Something is there, so it turns this way, and then it goes straight. Well, then it goes out, but it doesn't turn the same way every time. So.
Can you talk a little bit about the problem, the perfect 90 degrees?
Oh yeah, like I looked up to see if I could make it turn 90 degrees, but like the reason that it won't turn 90 degrees all the time is because it's like basically there's these two motors here that are powering the track, and they don't always get to the exact same amount of power, so they won't be able to make perfect turns all the time.
Is it because of the track or because of it doesn't have wheels?
I don't think wheels really make a difference. It's because like these motors won't always get like the exact same amount of power, so there'll be slight variations, and that's enough to throw it off when you have like 4 or 5 turns.
But also the friction, the surface could cause it to be off too.
I had some problems when I was starting at a different location. Sometimes the track would be caught on this part, and that messed it up too.
And can you talk a little bit about how you started the project? I mean, you didn't just start it and decide you're going to do this. What did you?
Yeah, like,
Build
as
some
I
other things.
mentioned, so that I wouldn't try doing some of like the like little basic robot designs that I had to get a hang of the programming and like how it works and what block is what and how I would get it to do certain things. And yeah, I decided on doing a maze because that seemed like it would be fairly simple to do. Yeah. Any other questions?
The maze doesn't have to do with the programming, the kind of the structure.
Yeah, like you could change up the maze to go. You could like move the blocks down, and it would like theoretically do that. You could still go through the maze as long as there was like something here. So it would, as long as the maze, like if you wanted to turn one way, like there wouldn't, like if you wanted to turn like this way, there'd be something for it to sense. Yeah.
Some sort of.
So if you did set it up so it went straight down into that corner, it would just stall, wouldn't it?
It would, like if
Or
it
we
went
didn't
this
know
way.
how to back up.
Oh no, it wouldn't know how to back up. It's
Okay.
not programmed that way.
Yeah.
It would get trapped in the corner.
So computers will only do exactly what you tell them. And
Yeah, they'll do exactly what you tell them, no more.
you can fool them.
Yeah.
Which I personally think is a really important lesson for a lot of people to learn and understand. Because they think, wow, computer's just going to solve that problem. No, computer's going to do what you told it to do. And if you told it to do a bad calculation, you will get a bad answer. If you program it or in such a way that it always turns left regardless of whether there's something in the way, then it's going to stall sometimes.
Yeah.
Or if you set up your maze so that the robot isn't, the rules that you gave it, it isn't going to be able to work, then it isn't going to work. So it's, you know, computers are not infallible.
Okay, and so then there's a lot of other, do you want to show the GUI and show some of the other types of robots you can build with?
Yeah, right.
Yeah, we got one right here.
Yeah, this is one of them.
This one is, I don't know if you can program it.
I think
We can